Okay, so they're giving us a function 1 over 1 minus 2x. So they've summed up the series somehow and gotten to this function. They want us to write the first 5 terms. Again, we can do this by taking the derivatives and creating the series, but again, this is the sum of a geometric series. So if you recognize that, this will be much simpler. So I know that a is 1, your r is 2x, so f of x, which is equal to this, is the same as 1, and then you're just multiplying by 2x every time, plus 2x, and I'm just going to write it like this. Don't simplify it. And I want the first 5 terms. So I've got 1, 2, 3, 4, 5. I need one more. And it does not ask for the general term, so just give them the first 5. But this is not correct yet. F of x is not just these first 5 terms. It goes on forever, so make sure you put the plus dot 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 for the series. Okay, part B, find the interval of convergence. If you recognize it was a geometric, we don't have to do the ratio test. Geometric series says that it converges if absolute value r is less than 1. That's it. And for a geometric series, it always diverges at the endpoints, so I do not need to check the endpoints here. This is it, you're done. Now, if you did not recognize it was a geometric, but started doing the ratio test and created a general term, that would be fine, but then you would have to show them that you did check the endpoints. Okay. Last part, part C, this is kind of going all the way back to something from chapter 8, a little bit of a challenge here. They're telling you that g of x is defined by this. And they want you to use partial fractions. So if you remember, partial fractions is where you take this fraction and you split it up into 2 separate fractions. And what you have to do is try to figure out, oh, what do these numbers a and b's have to be? And if you remember, this is kind of the shortcut for it. Instead of solving it, you're going to take one of the zeros of the bottom, so x equals 1, and you're going to go ahead and cover that up. And then if you plug that in, whatever number you get after you cover this up, which in this case, if I plug in 1, I get -1, that will be the value above the 0 that it came from. So -1 is b. Let's do the other 0. So x equals 1/2 is the other 0. So I'm going to cover it up and plug it into this, and if I plug in 0 there, I'm sorry, 1/2 there, you'll get 1 minus 1/2 on the bottom, which is 1/2, but then flip it, so you'll get 2, and that becomes a. So g of x is really, a is 2, so 2 over 1 minus 2x minus b is -1, so 1 over 1 minus x. So we have rewritten this problem as 2 separate fractions. That's what we're doing. And now what they're saying is, okay, now you have g of x written as partial fractions. Can you come up with the first 5 terms of this? And what you want to recognize is that these are also geometric series. A over 1 minus r, a over 1 minus r. So this would be, I'm going to just pull that 2 in the front. So my first term here is 1, and r is 2x, so I'm just going to multiply by 2x every single time. Multiply by another 2x, and they want the first 5 terms. So 1, 2, 3, 4, one more. And this goes on forever, plus dot, dot, dot. So this is just this piece right here. And then I want to subtract off this series. This is also a geometric series, a over 1 minus r. So I'm going to subtract off all of these terms, the first 5 terms, 1 plus x squared plus x cubed plus x to the 4th plus dot, dot, dot. Now, they want the first 5 terms, so you will have to think about combining your like terms. And if you do that, well, my first term is 2. I'm subtracting off a 1. So my first term, when I combine like terms, is 1. My second term here is 4x. If I distribute that negative, you have a minus x, so my next term is 3x. Then my next term is 8x squared. Subtract off an x squared. And just keep doing that, and we need to get to first 5 terms. And you get to here. So g of x is this series.